So what we're going to do is we're going to look at some enzyme kinetics data. Now, I'm a biochemist, and so this is something biochemists do all the time. And so we'll go through this, and this is really about curve fitting. And we're going to be doing some nonlinear least squares curve fitting in Python. And in this first module for the next half hour or so, we're going to learn to create a Pandas data frame, which is a data structure that Python can use very effectively to get our enzyme kinetics data into a form we can use. And then we're going to do some calculations and add those to the data frame. And then we're going to do some nonlinear regression calculations. And then in the next unit, we'll come back and do, we'll do some linear regression calculations in this unit, and then do some nonlinear in the next unit. And so Pandas, just to explain a little bit about what Pandas is. Well, if you think Pandas is a data structure that's, in my mind, it's kind of analogous to an Excel spreadsheet, only a lot more powerful and a lot more useful. So if you think about a 1D array, it's just a list, like those lists of concentrations and so forth that were generated in the last unit, the last module. A 2D array is something that has rows and columns, like a spreadsheet. That'd be an example of a 2D array. A 3-dimensional array would be a collection of 2-dimensional arrays. So that might be, you might have XY coordinates, XYZ coordinates for some object as a function of time. And so that would be a 3-dimensional array. And NumPy is a Pandas library that can handle 3-dimensional arrays. Pandas only does 2D arrays, but it's got a lot of really clever and useful things built into it that we can use. And if you look at the book, I'm not going to talk about the materials, but there's some links here to some great resources about using Pandas. And so as you are doing this, hopefully you'll be able to see some things that you want to use. And when you see those things, you can come back, or you can see an application for what we're doing right here. And then you can come back and actually solve your own problems. So if we're going to use Pandas and other libraries, we have to import them first. So the materials that the cells that were executed in the previous module weren't based on special libraries. A library is a set of functions. And so we're going to import several libraries here to use in this notebook. So the first, and the command here is just import, I-M-P-O-R-T. And we're going to import a library called OS. And OS is for working with files and directories. We're also going to import pandas, so I-M-P-O-R-T, pandas, all lowercase, as PD. Now we do the as PD just to make it easier to call things when we want to use a function in pandas. And then we're also going to import, or actually another import command is from SciPy, which is another library. We're going to import part of that directly into our memory. It's called stats. And we'll use this to do the linear regression. So when I execute those things, those three libraries are loaded now. The next thing we're going to do is create a file handle for the CSV file that contains the data. Now, if you look at my screen, I'm operating in Jupyter Lab mode here, and there's a folder here called data. And so the file we want is in there, and it's called apkin.csv. We'll come back and use that. So to create that file handle, we're actually going to call it data file. Say data file equals os.path.join. So we're pulling some functions that are in the OS library, then an open parentheses, and then I'm going to type in data. That refers to the folder we want. And then within that folder, I should say the data is in quotes. I'm using single quotes. You could use single quotes or double quotes. And then in the second set of quotes, I'm going to put in ap_kin.csv. And it's very important in Python, very fussy about uppercase and lowercase. You have to be exact. And so that will create the data file. And I'm just going to print the data file to make sure I've got it right. And so this tells me the data file is pointing to the file ap_kin.csv in the folder data. Now that just tells me what it's pointing to. It doesn't tell me if I got the right things. It just tells me that's where it's pointing. All right. So what we're going to do now is we're going to create a Pandas data frame from this. And so the Pandas data frame, whoops, scroll the wrong window. So to create that Pandas data frame, what I'm going to create a variable here, AP_kin. And so that tells me that's where the data is going to be related to. And I put an underscore and a df. That df afterwards, I just like to have that when I'm creating data frames so that I know that this is a data frame. So we're going to set that to be equal to PD. Now, when I put in PD, remember earlier I said import pandas as PD. So this is telling me look in the pandas library for a function. And the function I'm going to use is called read_CSV. And then open or parentheses and put in data file. Close the parentheses. And so that's the command that will help us to set up a data frame. And I want to look in that data frame and see what's there. So I'm going to put in the command here, AP_kin_df. And then after that, I've got a period. I'm going to type in head with an open and close parentheses. Now, let me explain what's going on here.
Hey, Paul,
Yes.
could you scroll a little up just to see the previous command? Because I missed. Thank you. Thank you very much.
Okay, no problem. Thanks for speaking up. All right. So the AP_kin_df, that's the data frame we're calling. The dot, that means we're going to call some function that's associated with data frames. And we can do that because this is a data frame. And then the open and close parentheses follow a function. So if I hit return on this, or control return, what we see here is this is our data frame. Actually, it's the first 5 lines of our data frame. And that's what the head command does. It only shows us the first 5 lines. In this case, the data frame is only 11 lines, so it's not that big of a deal. But you might create a data frame that has 1,000 lines in it. And if you didn't put in head, you just put in AP_kin_df, it'd print up all 1,000 lines and fill up your screen. You wouldn't want that. So this tells us that, in fact, we have imported the data into a data frame. And I want to see, I'd like you to show the red check, I'm sorry, the green check if you got that to work, and the red X if you didn't. So if we could see that in the responses. Okay. Okay, we've got a couple of folks that are putting up no's. That probably means that there's some character you have wrong. For example, Python is very fussy about the differences, Jessica already pointed out, the differences between parentheses, square brackets, and curly brackets. So make sure you've got the right parentheses here. Also, make sure the names you have are correct. And you've got the capitalization and uppercase and lowercase correct. And that, for example, the AP_kin_df dot head, that period has to be there for this to work properly. And if you're having trouble, then one of the helpers will be, you can go into one of our breakout rooms and get some assistance with that. All right. So we have this data frame. And notice that the first column here, 0, 1, 2, 3, 4, that's what we call the index. And for this particular problem, we actually, and so that if this were X, Y values, those would be the X values. And for this particular problem, we want to actually have the time values here as the index so that we can use that for determining some rates. So what we're going to do is we're going to replace the index that's shown here with the values in the time column. And the expression is shown right here. we'll just go ahead and type it in. So it's, once again, AP underscore KIN underscore DF dot set underscore index. So that's a command that applies to data frames. Open a parentheses, and in quotes, we're going to put the name of the column that we want to have as the index. So it's going to be time. So capital TIME, a space there, open a parentheses, min, close the parentheses, and then close the quote. And then after that, I'm going to put something called in place equals true. And what this does is this actually sets it so that it's permanent. So it permanently changes the data frame. If I didn't put the in place equals true, it would set that as the index just for this cell. But when we went to the next cell, the 0, 1, 2, 3, 4 would be the index again. So in place equals true. Notice when I type in true, the font color changes. That's because true is a reserved word. So you don't want to declare a variable and call it true in Python. And I want to check and make sure that I actually did that right. And so I'm actually going to ask it to show me the first 5 lines. Set index, sorry. Head, open and close parentheses. And I put it in. And you can see now that in the first column, which is our index, we have these values. And at the head of each of the other columns is actually the substrate concentration. Now, we want to make sure we've got the right data type in here. I mean, these numbers, you know, for example, in this cell I'm pointing at under the 20.0, 0.127118, that's almost certainly a decimal number. I forgot what decimal numbers are called. I can't believe that. What's a decimal number called in Python?
Float.
A float.
Could you quickly scroll back up to the loading of, or the importing of Pandas and the creation of the data frame?
Okay.
Sorry, there's just a couple people that were held back.
Okay. Thank you. Thanks for speaking
One
up.
line above, if that's all right.
Sure.
Yeah, there we go. We need the imports also.
Yep. All right.
Is that import OS the first one?
Yeah, import OS was the first one we imported. Yep. Well, a couple folks are catching up. I wanted to mention that Ben Pritchard is one of the helpers today. He was actually a student at RIT where I teach, and I actually found out when I spent spring semester there with the folks at Mulsey that Ben actually took a biochemistry course with me way in the past. All right. Okay, is that resolved now? Can I move forward?
Let me check. Sorry.
Okay.
Yeah, I think we're good.
Okay, good. All right, so one thing we want to do is we want to make sure that the data type for the elements in this time column are also floats, okay? So what I'm going to do is I'm going to go in here and use the command type, actually dtype, okay? And I'm going to use this to refer to the index. So AP can underscore DF dot index. So index, once again, is that first column. And I type in dtype. And it comes back and it tells me that these are floats. Okay, so we're good to go. So the next thing we want to do with the data here is we want to calculate the initial velocity. And so the process we go through here is I've written out 5 steps here. We'll go through them one at a time. The first step is to inspect the data. And then once we've done that and we're sure that it's going to behave itself, we create a second data frame with a substrate concentration as the first series. And that will become important when we get to the next module. Then we're going to calculate the slopes from the first data frame and add those as a column to the second data frame. And then in that second data frame, we're going to calculate the initial velocities by dividing the slope of those lines by the extinction coefficient for the substrate. In this case, it's paranitrophenol, that's the product under these conditions. And then we're going to export that second data frame to a CSV file that we can use in the next module. So once we've completed these 5 steps, that'll be the end of this module, and we can move on. Actually, that'll be time for questions and for hands-on exercise. So, as I mentioned before, Pandas has a lot of useful things built into it. If you want to do detailed plotting and very elegant and beautiful publication-style graphs, there are a lot of other plotting libraries in Python, such as matplotlib. But for data frames, if you just want to inspect the data, just want to take a look at it, and you can use this command dataframe.plot. Okay, and so in our case, our data frame is called AP_kin_df. I'm going to follow that by typing in a period, so dot plot, open and close parentheses. And this is going to enable us to actually see our data. So I'm going to hit the execute, and you should now as well. Now, notice that it took a couple seconds for that to come up. All right. And what happens in a Jupyter notebook while you're waiting for something to run, you actually see an asterisk or something here where the number 6 is currently. And so we can look at our data here, and we can see that we have a series of lines here. And what I'd like folks to do is to give me a reaction, a yes or a no, to indicate whether you're actually seeing the plot here. And if you check a no, that's fine. One of the helpers will come and see if they can catch you up. Looks like most people are in pretty good shape. Now, I like to have fun in Python, and I like plotting. I like the way things show up, and so I can go in here and in this same command, this dot plot command, I could say marker equals. If I put a lowercase o in that bracket and hit Control Enter, then I see the lines here. All right. I can also put in a dot, and I get a smaller point there. Turns out I can put in the number 3, and I get a different kind, an upside down triangle. So there's a bunch of options there. So I'm going to take a minute, just let you go in and have some fun with that. And you're gonna try some things, like if you put in a Z, it doesn't, whoa, what happened? It went away. It's wrestling with it. All right. And then it gave me this huge long error message. But at the bottom, actually, this is instructive. When you put something in error into one of these cells and Control Enter, you might see a very long list of errors and problems. And that can be overwhelming. It certainly was for me when I first started doing anything in Jupyter Notebooks. But I learned very quickly, you look at the very last thing. And the last thing tells us unrecognized marker style Z, doesn't like it. All right. So I'm going to get rid of that and get rid of all the errors and go back to O. So if we look at our data here, we're going from lowest substrate concentration here on the bottom to highest on the top. And you can see that in general, the slope of each curve gets a little steeper as you go to a higher concentration. And also that the curves get closer together as you get to the upper limits of the concentration. So that's an inspection of the data, and it looks like our data are good. Now, when I was preparing for today, I went and I hit this command, and the data looked terrible. And I realized I'd made a mistake in the way I imported the CSV file into the data frame. So what we're going to do now is we're going to create a second data frame that contains a substrate concentration. as its first feature. And we're going to use this data frame to actually eventually for the nonlinear regression. But right now in this data frame, what I'm going to call the data frame capital MM underscore DF. I'm a biochemist. MM stands for Michaelis-Menten. Okay, it's a standard form of kinetics. And MM underscore DF equals, now I type in PD for pandas, put a period, that will tell Python, look for a function inside that's available in pandas, in the pandas library. Then I type in data frame. Now notice data frame has capital D and capital F. Okay, very exact, you have to do it that way. And then I have an open and closed parentheses. So that will create a data frame. And then what I'm going to do is I type in MM underscore DF equals, MM underscore DF, and then an open square bracket. Okay, it's a square bracket, not a parentheses or a curly bracket. And then I'm going to type in P, lowercase p, capital N, PP. And then open a parentheses M, lowercase m, uppercase m for millimolar. I'm going to close that quote, close the square bracket. And then what I'm going to do is I'm going to go back to our previous data frame, and I want to grab the header for each of these columns, the 20, 10, 7, and so forth. And so what I do is I'm going to say this is equal to AP underscore KIN underscore DF dot columns. And so that's actually going to pull the header from each of those columns and put it in the column in our new data frame called PNPP millimolar. And then if I type in MM underscore DF and hit Shift Enter, there's our new data frame. Okay. Now, what I'd like to do at this point is to clear the responses so I can call for a new response. And
I got it.
You got it? Okay, great. Okay, so please give a check mark if this is working for you, and give an X, the red X, if it's not. Okay, I'm seeing a fair number of yeses. Once again, if you're having trouble, one of the helpers is, we're watching the list. They are watching the list. I'm not, but they're watching the list, and they can step in and help. You can also put a question in the chat room, or you can go to a breakout room. And the helpers are watching the breakout rooms. If you drop into one, they'll join you and help with that. All right, so we've got our second data frame with the concentrations in the first column. Now what we want to do is we want to calculate the slopes. So we've got all of these lines in the plot. So how do we get the slopes of those lines? Now earlier, when we imported functions, one of the import commands was from SciPy import stats. And so we're going to use a function from the stats library in SciPy that will calculate the slope for us. Now, this particular function actually returns 5 values. It returns the slope, the intercept, the R value, the P value, and the standard error. Well, we don't want, and the only thing we want is the slope. But if I put in slope equals that function, it gives me an error because it wants to give 5 kinds of values. So what I do is I'm just going to put in an underscore there instead of a variable name, and it'll just dump stuff in there, and we can ignore it. So to do this process, the first thing we'll do is we're going to create an empty list to hold the slopes. So I'm just going to call that slopes, S-L-O-P-E-S, equals an open square bracket, close square bracket. So that will create a list for us. And the next thing we're going to do is we're going to calculate those slopes. And we're going to use a for loop that, as Jessica showed you before, what we're going to say here in this for loop is for, F-O-R, columns, I'm sorry, column in AP underscore kin underscore DF dot columns. So this is a for loop, and this is telling the for loop that it's going to look in the columns in this data frame, and I follow that with a colon. Then when I hit return, then Python automatically indents here, and I'm going to put in the function that we want to use. So this is slope, comma, and that's the variable we want to capture. We don't care about the other four, so I'm just putting in underscore, comma, underscore, comma, underscore, comma, underscore, comma. Oh, no comma on the last one, we don't need that. Equals stats. So this is a library we imported before, followed by a period. That tells us to look in that library for a function. The function we want is called linregress, L-I-N-R-E-G-R-E-S-S. And if we look at the function, we can see that up here, as it's defined, we need X data and Y data. So we need to put the X data in first. Well, the X data is going to be that first, the index in the first data frame. That index is called AP underscore kin underscore DF dot index. So those are our X values. And then the Y values are going to be AP underscore kin underscore DF, open square bracket, column, close square bracket, close parentheses. So this function, once again, we're going to capture the slope for one of the columns, and the index, the X values stay the same, but it's going to scroll through the different columns in that data frame. And I actually want to capture that information. So what I'm going to say here now is slopes dot append slopes, append slope. So once again, slopes is the list we created here. And so the dot append command adds the latest value of the slope we just calculated to this list of slopes. And so now we have that. And the question is, did it work? So what I'm going to do is just type slopes here and see if it works. Then what we did should give us a list of 11 slopes. So control return, and we have a list of 11 slopes here. I feel like I should be checking each time to make sure this worked for folks. So please give the yes check if it worked, and the no X if it did not. Okay. Seeing a fair number of yeses and a few nos. Okay, can the helpers, is there something I could do at this point to resolve the issue for people who are having trouble? All right, so now what we want to do is add those slopes to our data frame. And so we've got this list of slopes. And all I'm going to do is I type in underscore DF, open a square bracket, single quote, slopes, close a single quote, close the square bracket, equals slopes. And I want to check and make sure if that happens. So I'm going to type in MMDF and look and see what we've got. So now we have a data frame with the substrate concentration here, PNPP, in the first column. So here's our index. The next column is PNPP. The next column is the slope. Now we want to calculate the initial velocity. And the initial velocity is just a simple math function that we need to go through. So what I'm going to do here is we're working with the same data frame now, MM_DF. Open square bracket, put a quote, call it initial velocities. Close that square bracket. I'm going to say that equals to MM_DF, quote, slopes divided by 0.015. 0.015 is the micromolar extinction coefficient for our product, paranitrophenol. And then I'm going to take a look at the database again. Now we have 3 columns. And I think for the sake of making sure that people are all up to speed on this, I'm looking at the clock. I think I'm going to slow down right now and check and see if we can get everybody caught up to speed on this. Okay, so give me a reaction. Do you see a data frame like the one I have here?
Hey, Paul, could you scroll a little up? I think there, yes.
Yeah, I see a note in the chat that one of our participants is trying to get into a breakout room. Scroll up to slopes. Okay. Is this what you need?
I have a question. Could you explain what does it mean slope and that dashes, because I was trying to do something else and
Okay. Yes. All
I
right.
got lost.
I think you're asking about this function right here.
Yes,
Slope
exactly.
with the underscores. Okay. So this function, linregress, is part of the stats library, and it accepts values for the x variable, the independent variable, the x data, and for the y data. So that's what this is in this parentheses. And it produces it calculates 5 values based on the x data and the y data. Calculates the slope. The next is the intercept, then the R value, the P value, and this, I think, standard error. And for our purposes, we only want slope. We don't care about the other values for this particular exercise. And so I just put an underscore in there. And what happens then is that the program will just keep replacing whatever value is in the underscore variable with a new value, but we don't care because we're just going to stop there. And so now we have the slope here, and it's going to calculate the slope. And we're in a for loop, so it's going to calculate the slope 1 column at a time. And after it calculates the slope, the next command here, slopes.append slope, that adds the new slope we just calculated to the list slopes that we created. So I'm going to scroll up to the data frame that we use to calculate the slopes. It's right here. And I'm actually going to show the entire data frame. Whoops. It won't do that. Oh, you know what? I think I've changed the data frame. So I
Maybe
can't,
because you already changed to set the index to
I
frame.
already changed it, so I can't do that. Okay, and if you have a more complicated problem or something's really giving you issues, please go to a breakout room and a helper. Oh, if you go into a breakout room, let a helper know. That would be good too.
So if you go to a breakout room, like send a message to the person who's supposed to be in your breakout room, because we're answering a lot of chats like in private messages. So we're not able to watch the private message chat and the breakout rooms at the same time. So if you go into a breakout room, send us a message and let us know, and we'll join you in there.
Okay, so we're at the point where we now
Also,
have.
sorry, can I interrupt for just a moment? Could everyone please send direct messages to the people who are assigned your letter? Because otherwise, I don't know who you're talking to, and it's hard to respond to the people who need help. That's all. Sorry.
And how can they find out who it is they're assigned to?
If you look at the breakout rooms, it has each helper and the letters that are in their jurisdiction.
Okay. Okay, good.
Yes, Paul, could you now scroll down? Keep.
Okay. Let me make sure somebody had the question. So we created the slopes. So now we have a list of our slopes. And so the next thing we do with these slopes is we want to add them to the data frame. And so all I have to do that is this command mm_df, and then I'm actually creating a new column in the data frame. And so when I do this, open the square bracket, and I have slopes in quotes, close the square bracket, and I say that equals slopes. First of all, when I do this, it tells Pandas to create another column in that data frame. Okay. And then when I say equals slopes, then it's actually going to take the values in that slopes list and put it in that column in the data frame. And so that's all that happened when I did this command. And so now we have our data frame with the substrate concentration and the slopes of the curves.
Got it.
Okay. And now biochemists would want to take those slopes and convert those to actual initial velocities based on the extinction coefficient or the absorbance of the product, in this case, paranitrophenol. And so all we have to do to do that, now that we have our slopes in the data frame, we go down here, we say mm_df, and then we have another square bracket, initial velocities, close that square bracket. That's going to tell Pandas to create another column in the data frame. And I say then that's equal to mmdf, or the data frame slopes. So this refers to the values in this column called slopes. It's going to divide those by 0.015. And then when I execute, we get this new or this updated data frame with an additional column with the initial velocities in it. All right. So the next thing we need to do is we want to set these data up so that we can send them. We can use them in the next exercise. So what I'm going to do first is eventually I'm going to want to have these substrate concentrations as the index. So I'm going to set that right now before we make the CSV file. So this is very similar to what we did before, mm_df dot set_index. So this is calling the set index function in Pandas, and open a parentheses, and I put in PNPP, and the capitalization has to be exactly the way it is in the data frame. And in fact, the spacing has to be exactly the same as well. And I'm going to say again, in place equals true. And that's going to make it permanent. And I want to take a look at that data frame to see if in fact this happened. MM_DF. I just look at the data frame. And we can see now that we've got our index. These are the substrate concentrations, the PNPP millimolar values. Our slopes are the second column. We don't really need those anymore. And initial velocities are in this last column. And so what we need to do now is we need to actually send this to a CSV file so that we can open it up in the next module or the next notebook. And so to do this, I'm just creating a name. I'm creating a variable here, output file. And that's going to be equal to os.path.join. So once again, we're doing this so we can save the data in a place where we can find it. I'm going to put it in that data folder. And I'm going to call it mm_data.csv. I want to be consistent. I'll use single quotes here, mm_data.csv. I'm going to close the parentheses. And now, and then what I'm going to say then is mm_df to CSV. So to_CSV is another Pandas function. Output file. So it's sending it to that. And before I execute this command, I'm going to open the data folder. And what we're going to see then is, I probably did this a couple days ago. So there's a file here called mmdata already. But when I execute this file, what you're going to see is that this changes from 2 days ago to seconds ago. Okay. Okay, question is, what was the formula for MMDF slopes? For the MMDF slopes, that's up here, and that was just equal to slopes. All right, and once you have that in slopes, type in mm_df to make sure it looks right. Then you'll need to create the initial velocities. And I think I'm going to stop here. We do have an exercise on the bottom of this page, basically taking another set of data and doing a similar thing to it. And you're encouraged to do that on your own just to get the feeling for it. But I'm not going to go there because I want to give people a chance to make sure we're all in sync here. At this point, I will open it up to questions from everybody.
What exactly here PNPP implies?
Oh, well, PNPP, that stands for paranitrophenyl phosphate.
Oh, okay.
So that's a
Okay.
substrate for an
Yeah.
enzymatically catalyzed reaction. I should mention these are data from a simulated reaction by an enzyme called peroxidase. So
Okay.
peroxidase cleaves paranitrophenyl phosphate to get
Uh-huh.
paranitrophenol. And I realize as a chemist, I should have shown a chemical equation for that reaction.
Okay, thank you.
Yeah.
How about if we want to change from CSV to any other data form? Are there any what do we do?
There are
That-
commands. We're only looking at, we imported a CSV into a data frame. We exported the data from a data frame to a CSV. It's also possible to do that with Excel files. But we're not doing that here, but there are instructions on how to do that. So if you just do an internet search, Python, if you type even Pandas Excel files, they'll tell you that. There's some links at the top of this notebook for Corey Schaefer's YouTube videos on Pandas, and they're very good, very helpful.